All right, let's get right into it. Today, we're going to tackle a huge climate mystery. And what's really fascinating is how two totally different groups with completely different ways of understanding the world ended up at the exact same pretty shocking conclusion.
So, when you see a picture like this, what's the first thing that comes to mind? Melting glaciers, right? And we all kind of assume it's because the air is getting warmer. I mean, it just makes sense. But what if the most obvious answer isn't the real one?
Yeah, what if the biggest danger is the one you can't even see? We're going to dig into this really wild idea that the #1 threat to these giant sheets of ice isn't coming from the sky at all. It's coming from deep in the ocean below.
To start to unravel this, we have to turn to the people who know this environment better than anyone. We're talking about the Inuit hunters and fishers of the Arctic. Their knowledge isn't just a collection of stories, it's a system built over thousands of years of careful observation.
For years, they've been seeing huge changes. And it starts with the most obvious thing. Just like this hunter from Baffin Island says, the big difference is the weather. It seems to be heating up. He mentioned that temperatures used to hit -40 or 50 Celsius all the time. Now, not so much. That's a massive shift.
And with that warming, you get new neighbors. We're talking cranes, salmon, catfish, even dragonflies. These are species that just were never there before. Imagine living your whole life in a place and suddenly seeing completely new animals show up. It's a sign that the entire ecosystem is being rewired.
And it's not just the animals. It's the ice itself, the very foundation of their world. It's changing. It's freezing a whole month later than it used to, and it's not smooth and reliable anymore. Now it's rough. It's unpredictable. That changes everything.
And this is where it gets really interesting. This quote is key. Some of the elders are saying, yeah, the warmer weather is coming from up there, from the sky. But then you have others, the ones with what they call the real knowledge, and they're pointing somewhere else entirely. They're saying the warmth is coming from the ocean. That is a huge claim, and it points us toward a totally hidden cause.
Now, let's switch gears and look at a completely different group of experts, NASA scientists. They launched this massive mission to figure out what in the world was going on in the waters around Greenland.
And you gotta love the name of their project. It was a 5-year mission called OMG. Yep, which stands for Oceans Melting Greenland. Seriously, you can't make this stuff up. And their goal was to study the entire 27,000-mile coastline, a huge undertaking.
So how'd they do it? Well, it was pretty cool, actually. They flew a plane over the coastline and just dropped these sensor probes into the ocean, 250 of them. As these things sank, they were constantly measuring temperature and saltiness all the way down to the bottom, and then beaming all that data right back up to the plane.
And this is what all that data showed them. Just look at this diagram, especially the one labeled A. What you're seeing is a cross-section of a glacier. The data reveal two totally different layers of water. You've got that cold, fresh polar water up top, but look deeper. That labeled AW is Atlantic water. And get this, it's warmer and saltier, and it's flowing right up against the bottom of the glacier, literally eating away at its base from below.
And this wasn't some isolated thing. We're not talking about 1 or 2 glaciers. The OMG mission found 74 major glaciers sitting in these deep canyons of water, getting melted from the bottom up by this warm Atlantic current. Okay, so let's just take a step back here. We now have 2 completely different lines of evidence, right? One is from generations of lived experience, and the other is from high-tech remote sensing. And they are both pointing to the exact same thing.
I mean, how incredible is this? On one hand, you have the real knowledge of the Inuit, passed down for who knows how long, saying the warm weather is coming from the ocean. And on the other, you have NASA's massive 5-year data gathering mission, which found a deep layer of warm Atlantic water is melting glaciers from below. It's the exact same story.
But this brings up a huge question, maybe one you've been wondering about. Wait a minute, doesn't heat rise? That's like Physics 101. So why is the warmest water sitting at the very bottom of the ocean? What is going on here?
The answer in one word is density. It turns out it's not just about heat. It's also about salt. That warmer water coming up from the Atlantic is way saltier than the cold Arctic water, and all that salt makes it heavier. It makes it more dense. So it literally sinks, sliding right underneath the colder, fresher water on top, and creating this hidden glacier melting layer right at the bottom.
So now that we understand this hidden mechanism, the big question is, what can we actually do about it? Because knowing the real problem is the only way to find a real solution.
Well, with this unified understanding, scientists can build way better models to predict what's going to happen. This one here is a great example. It shows all the complex ways energy moves around. You can see the warm water making direct contact with the glacier. And the beauty of these models is that you can use them to test out potential solutions and see what might actually work.
And it really boils down to two main ideas. The first one is the big global approach. Reduce CO2 emissions to stop warming the oceans in the first place. That's the long-term fix. The second idea is more of a targeted local defense, the idea of literally building something like an underwater wall, a berm, to physically block that warm water from getting to the most at-risk glaciers. A much faster, but more targeted solution.
So what's the big idea here? What should we really take away from this incredible story of discovery? I think it's this. To solve the really messy, complicated problems we're facing, we have to combine rigorous data with lived, multi-generational experience. It's not about data science versus indigenous knowledge. They're not in competition. They're two sides of the same coin. And when you put them together, you get a much clearer, more complete picture of what's really going on.
And that leaves us with one final question to think about. This story, it's not really just about melting ice. It's about how we learn and who we decide to listen to when the stakes get this high. It makes you wonder, right? What other huge problems could we crack if we started bringing all kinds of expertise to the table?